start our wall building is for our bottom plate on our wall, we want to pick one of our better boards because it'll just set up everything easier for us to do. So I'm going to try to kneel and show this. So we look down our board for straightness, sight both sides. Some boards you'll see they'll really walk, some will be really twisted. This one has a little bit of wood missing on this edge. We're fine with that. That is not going to be a problem for where we're putting it. It also sits pretty flat, has a little bit of a rock, but not bad. I think we can take that out of this board. And so we've gone through our pile of lumber to find one of our better boards. It doesn't have a ton of knots. It's also not directly a heartwood board. The center of the tree is not right in the middle, which is more likely to cause it to twist, warp, or crack. My rings of my tree, I don't see the center of my tree in this board. Okay, we have a bottom plate we're ready to work with. This one, if we were using this board, which looks like a bridge, has a huge bow in it, we could still use it. We are still going to use it. One of the things is we want to take this curve and we want to make sure we're using it in such a way that we will be sucking it down and flattening it out. This curve is not a problem. It will not cause us too much mayhem, but we do need to use it. If we flipped it over and used it like a boat, it'll be a lot harder for us to flatten it. We'll have a much harder time straightening out this board. All right. Okay. Tools we need for laying out walls. We need our designs. We absolutely have to have gone through those because we need to know what's going into this wall. We need a tape measure. We need the pencil Margot showed us how to sharpen. And then we need a speed square. And we need our drawings so that we know exactly what we're putting into this wall. So that's the start of wall framing. All right. So for marking our wall, which we're doing showing really twisted studs here, we're essentially creating a layout with our pencils that is going to show where our studs are going to get screwed in and set. But we're doing that, instead of doing that with the scrap of 2x4, we're doing that with something that has cool little measurements called the speed square that sits square onto our boards and gives us our measurements. We know that the 2x6s we're working with are 1.5 inches wide. One of the cool things about speed squares is you can roll them on the board to mark both sides. So you have a mark you can see when you're screwing from the top, and you have a mark you can see when you're trying to line up your boards. Okay, what's the first thing we do with this board?
Make sure that it's the right length.
Bingo! Which is something I always forget. Okay. Because most dimensional lumber comes in a little bit longer.
Yep.
So what are we?
We are 12 foot and 3/4 of an inch.
Okay, so we need to knock 3/4 of an inch off this board. The first thing we're going to determine, are there any significant splits on one end or the other?
With the edge of the saw, making it so that I'm gonna have my
we're walking over.
My 0 over here lined up, and I'm actually gonna check also that, just making sure that the blade is gonna hit exactly where I want it to hit. And so having my speed square lined up, and I want to make sure that my hand is far enough away. I want to hold that speed square really steady, but I don't want my hand close to that saw blade. I also don't want my leg in the way of that saw blade. So I'm gonna start my saw with the blade not against the wood.
Okay, lovely. So Margot's just taken our 3/4 of an inch off our board, so we have exactly 12 feet of board. Okay, so right now we have a finished wall that's ready to be raised. This is the first of our north walls. there's two north walls because we have two different levels going on. Of course, nothing on this building is simple or standard, so we had to build it a little bit different than we would have. And this is where building walls in windy Wyoming becomes a problem because you can't hear anything past this because of the darn wind in the microphone. I do want to remind you at this point that if you have a building department, you are going to have building codes for your walls. Please know what those are. Also, if you have reached this stage without finalizing your design, do not start building walls. This is where you really need to know what all your details are, all your window openings, all your doors, all your utilities, how everything's connecting, details, details, details. We built this wall the reverse of how I normally do. This is actually the inside of the wall because this window header that we're using has 3 flat sides and then 1 rounded side, and we want that to the inside of our building. So there's a couple components to this wall. I just want to point out where they end up. We're going to be looking at, that's the double top plate, that's the top of the wall. That's a single bottom plate there. The double top plate is transferring our load across the whole wall. And then we have this big, beautiful window opening where the desk is going to go. That will be a lovely space. The windowsill that the window sits on has cripples. Those are called cripples that transfer the load of the windowsill down. The main load is transferred from the header to this jack stud. It's called a jack stud that transfers the load along down to our bottom plate. Normally, the outside full-length stud is called a king stud. Because this is a women's construction video, we're calling it a queen stud. So we have a queen stud on the outside, and then we've got a jack stud on the inside. Across here, we've got our window header, and then we've got the double top plate where we're putting our trusses for our roof. So our whole window assembly, what's really transferring the load, is this jack stud that takes it all the way to the floor, and the cripples that transfer the load of the double top plate down to the big burly header. And on the far side, we have the same thing. We have a jack stud underneath our window header, and then we've got a full king stud, or in our case, queen stud, running full length and making that whole area of the wall super stiff. Past that, we get into pretty standard wall framing. We've just got normal stud bays. In this case, we've got a couple that are on 16-inch centers, and then we have one at the very end that's on a 24-inch center. That's just how our spacing works. And the second to last stud on the very end is turned sideways and attached to the end stud. That's a corner stud, and that's going to allow us to have a place to attach drywall to on the inside of our building. If this was a normal wall and I was working on the outside of it right here, I would actually have attached wall sheathing after I squared up my wall to keep my whole wall square while I was raising it. Because we're working on the inside of the wall, because we have that rounded header, we've actually attached the temporary diagonals that will eventually take off once we get the walls up and square and part of the sheathing on, so that our wall stays square on us. Let's look at that wall one more time. So remember, our load for our wall is coming down from the top from our rafters and loading onto our double top plate. We then have to transfer it down our wall. In this case, we're going to transfer it down our full length king stud, or in our case, queen stud, along the edge, get it all the way to the bottom. And then we need to transfer that load as well, because we have a window opening, through our jack studs. They're on the inside, so they're going underneath the window header, and that's our jack stud. We'll have 2 of those, one on either side, supporting either side of that window header, which in our case is a full solid beefy header because this is a load-bearing wall. And then we have on the other side of that, to stiffen everything up and transfer the load, we have our second king or queen stud. If we needed a really stiff wall, we would add another one of those on the outside. On the top, to transfer the load to our header, in the empty space of the window, we'll have the cripples, and those are taking the load of the top plate and spreading it along our big burly header. On the bottom, not carrying anything but the load of the window, is our windowsill, which then has bottom cripples, which should only be supporting the weight of our window. Let's look at how our 2 walls tie together in the corner. So this is the corner of our west wall and our north wall. You notice our first top plate of the north wall goes full length, and our second top plate stops short, so that the west wall has a full length double top plate and then a short top plate underneath. So we have overlapping corners there to make a very strong interconnected corner. On the bottom, where this comes together, we have 3 studs in there, even though it doesn't look like it. Stud number 1 is part of the stud of the west wall. Number 2 and 3 are part of the north wall. Number 3 stud is attached to number 2 stud, and it's on the inside so that it sticks out into the room past the wall so that you can attach drywall to it. This is called a super insulated corner, so we can shove insulation in there. There are other ways to build corners, and that book on walls and framing by Taunton Press, I highly recommend for looking at the different options for building your corners. Thanks. Okay, so we're getting ready to build our interior 2x4 wall that separates our bathroom and our shower. And so we're going to show marking plates again. We're actually building this wall in place, so we put the bottom plate here down first. We measured equidistant all along this wall, so we're keeping parallel with our exterior wall, so our room stays the same width. We then put in our edge studs and we leveled them with a level on the side to make sure they're running where they are, and then we checked the width on top to make sure that's also still running parallel with the wall. Now that we have that done, I'm going to take my top plate. Remember, I figure out where my bow is in my top plate. In this case, my top plate bows out like this, so I want to mark my underside so I can see it when it's up top there to run my studs, because I'm actually screwing these in place, which makes it even harder than building it flat on the floor. This is how I'd probably do a wall if I was building in a remodel and couldn't stand it up from the floor. I'd build it in place as I went along. But I do want my marks to be consistent from side to side. So I'm going to transfer my marks with my handy dandy speed square over here and take all my marks and just transfer them straight across. I have my top plate of my wall pushed up flush against this wall here so I know it's lined up. And I'm just going to transfer these marks straight across. This helps me keep pocket. I have to actually talk and think as I go. This helps me keep everything parallel. I'm going to double check all of this with a level when I actually stand it up. But this gives me somewhere to start with and to screw it in and be like, oh, I'm just a little bit off, or oh, I need to level that more. Otherwise, I just have to hold the level and guess, and it gets a little harder. So yeah, and so I'll work my whole plate across, and then I'll start building my wall up. Okay, so real quick, we have raised our walls. We raised them with diagonals on them, which we actually had to move, so we'll have to recheck our diagonals on this wall to make sure this wall stayed square, both diagonals, before we put sheathing on. And then we put bracing on the outside of our walls, inside and outside, temporarily as plumb as we could, so with a level on it, so as level as it can be. And now we're going to check to make sure we actually have a 90-degree corner, because if our walls are not square to each other, we will fight this all the way through from drywall on. In a little building, it'll be small. In a bigger building, it'll get enormously bigger by the time you get a long way. So we're gonna make your math teacher so excited, because they're gonna be like, remember when I taught you Pythagorean's theorem and told you it would be useful in life? Guess what? It's useful in life if you're building walls. So a squared plus b squared equals c squared, to check to make sure you have a 90-degree angle. In our case, the largest form of that math we can use is the 3-4-5 rule. So I'm going to measure 3 feet out from my corner on one end of my triangle. I'm going to measure 4 feet out on the other, and then my diagonal should equal 5 feet. So I bring my tape in, I measure 3 feet, I make a careful tick mark, I do the same thing over here. I measure 4 feet. I make a careful tick mark. Then the only tricky part for doing the diagonal is making sure that I measure on the same side of my tape. So if I'm looking on the inside of my tape on that tick mark, then I need the inside for me actually being the side away from me, because I'm backwards. Inside would, for most people, would be toward them. That'd be great. Then I make sure I stay on that side of the tape. So at this point, I'm reading on this side of the tape, so I want to make sure my mark comes at this side of the tape, and I'm hitting exactly 5 feet. So that is checking exactly 5 feet at the bottom of my mark. So I have a 3, 4, 5 triangle. The larger the space, the larger the 3, 4, 5 rule you should get away with. It's all on the internet. You look it up or do the math.